Good morning, everyone. This is Jun Wang from Merck Discovery Chemistry High Throughput Purification Group. I'm so glad to get this opportunity to bring you this topic, data management and prediction to support high throughput purification workflow. In this topic, I'm going to cover three parts: background and contents, in which I'm going to introduce you what's a high throughput purification group and what business challenges we are facing. The second part we're going to be strategy and duration. In this part, we're going to talk about how we do our workflow integration, how we improve our data management, how can we achieve higher throughput. The last but not least part, we're going to be capabilities and road ahead. In this part, there are two tools from ACDLabs, Spectrals and Chromatographic will be discussed. And also we will mention some future enhancements. So first, let's talk about the background. The role of a high throughput purification lab. You might ask what HTP group is doing. Okay, so HTP group is serving as a high value group for discovery chemistry. We are providing routine and specialized purification and analytical support. From the top scheme, you can tell HTP is between discovery chemistry and the compound submission lab and discover biology. So chemistry will do the search, design work, they synthesize their compounds, then they will submit their compounds, of course, crew the compound mixture to HTP group. So we are going to work on the screen and purification work. Then we will analyze the collected fractions. We will dry down the fractions. We will get the report generated. Then we will send the material to compound submission lab or discovery biologists for following assays testing. Also, like compound transfers, they will supporting as well. So we purify compound from crude sample to pure dry product. We report weight and the purity information. We're also working on optimizations of purification methods, considering like purity, yield, throughput for maximal success. And also the investment in specialized, customized workflows and instrumentations. Try to adapt to many new technologies and technicals to make our workflow more efficiently. After introduction, let's dive into our workflow. So this whole picture is showing you how we handle samples and how we handle our information flow. So first, chemist will prepare the samples in various scales, like 0.5 mg to 100 mg. In 0.2 ml to 2 ml, they will prepare in like 96 well plate, which is well prepared, filtered, avoid any precipitation and clog in the instruments. They also run their crude LC-MS to get the pre-QC data, which we can refer to when we do our method selection. Once we get the submission, HTP group will start to work. So we will decide, should this sample go into reverse phase LC-MS or should we go SFC purification? And what's the scale of the sample? It's micro scale or prep scale. After all the considerations making, we were going to make our decision on which method to do the purification. After the purification is done, the pure fractions will be collected based on the desired mass. Then we will evaporate the liquid, left very dry, pure materials in this machine called Genovac. Then we'll weigh the materials like to see how much we recovered from the samples. Also, this robot called Ceres will also can support our liquid handling, such as preparing LC-MS sample. With those LC-MS sample in hand, we can run QC, like the purity check, to see how the purification is going, how the purity look like. So Now we have the weights, we have the materials, we have the purity informations. We can generate a report, then send the material to compound submission lab. So as you can tell, there are many steps in a whole HTP workflow. So what challenges we are facing? There are two-part challenges. First is about data, the data integrity and the management. At Merck, our data integrity is very important and required. However, in our workflow, there are many multiple modes and formats of data across the lab. There are so many different vendors, instruments, softwares. So the data captures in those individual computers. No easy way to share or perform analytics. Also, it's hard to do structure searching or data mining because they are not together, these data. Also, there are many manual steps when we do our report generation or even for chemists to submit their samples. And secondly, part is we are supporting so many modalities and samples. So it could be hard to achieve a high throughput or higher throughput. So the goal here is we are exploring a new platform to expand the access to the data within HTP and the chemistry department. And we hope we can get automated data flow to minimize the need to manual import. We also hope we can increase our speed to make it higher throughput, like we can get the data analysis and access more automatically. And we hope our data is safely protected and located through the whole life cycle. And also we are looking for some tool to kind of like speed up our workflow, which make it a higher throughput. With those goals in mind, let's talk about our strategies and visions. So as we are looking for a platform, so ACDLabs comes up. ACDLabs is a company who develops and provides software solutions for scientific research. There are two tools we are very interested in. First one is Spectros. Spectros is a multi-technical vendor-neutral analytical data handling tool. It can support many vendors. And ChromoGenius is another tool which can support the liquid chromatography rotation time prediction, which is very useful for our workflow. So later we are going to kind of like show you how these two tools can be applied into our whole workflow. Okay, first, let's talk about Spectros. On the right side, there's a picture shows which vendors on the market Spectros can support. There are many of them, and most of them on the market can be supported by Spectros. So as I circle out the Waters, Agilent, Thermo Fisher, Shimadzu are the instrumentations we use in our lab, and Spectros can support. That's perfect. So now let's talk about workflow integration and data management. So Spectros can support our integration of all the LC, MS data, UV data from all these vendors. And it can support auto or manual data processing and analysis. And we can view structures in records, and we can search by structure or any other parameters in the reports. And we can create reports with like structure assignment, add the method parameters, includes the chromatograms. So it supports all these functions. Also, Spectros is cloud-based database. It's very convenient to use and access from anywhere. So we are working on investigate the applications into different workflows, like for our small molecule module, like for our peptide modality, bioconjugate, prep scale, micro or mini scale, or even our SFC workflows. So here comes to the handling concept. First is overview how Spectros work. First, Spectros is a cloud-based database. And first is once the chemist submissions the request, all the information will go to the database. An HTTP group will take care of the purification whole workflow. So we will get the purification results file, go to the database, get the weights file, go to the database, get the purity check file, raw data, go to the database. With all this data in the database, we can check the database, process the database. After that, we can have our report from this database and also the registration SD file generated. More details will be talked about. First is this interface, which is a customized script developed for Merck. There are two specific buttons. One is for submit, one is for analyze. Once you click on the submit, you can do the request submission. In this window, you can put your ID information, how many samples you have, upload your SD file, and add any specific notes. And after the submission is done, we will receive notification. So HTTP will do the purification. After purification is done, we're going to click on this analyze button. This window will come up. So we will go to the database to check what we have: results file, weights file, and the purity data. Then we can click OK. Then Spectros will automatically process this whole thing for us. After the process is done, we can go into the database. So here is one database open up, which is a library including 17 samples. In this database, it includes SD file structure, metadata, purification results, weights file, raw data from MS, and all the other information. So you can click into each of them to look into the details or manual process your data. So after the introduction of all the concept of Spectros, here I want to talk about the second tool is chromatographic. Chromatographic is a tool can use to predict retention time and chromatograms based on the structures of the compounds to be separated, and allows you to select the best generic separation method for your sample before your injection, before your purification. So there are two steps in chromatography. First, you need to create a database. Then you use the database to do the prediction. So based on this tool, we hope we can achieve higher throughput. How we can achieve that, we will talk to you later about details. Okay, here just shows the first step, how you build a database. First, under the database tool, you can choose import data points from your Spectros database, which is we used. And after you import all the data points, you will get a library of all these data points and have your database built. After that, you can optimize in your database. There are many parameters you can work around, like similarity. There are different coefficients you can choose from. And about equations, you can choose like which parameters to use to generate your equation. Also, some other parameters you can change, you can check, uncheck as well. After the database is optimized, you can now use for prediction work. So here's one example from ACDLabs. So once they have a database, this is a 4-minute UPLC method. They imported 3 new structures, and the software will choose here, for example, they choose 20 structures from the database, which have very close structure similarities to these 3 new compounds. Then it finishes the prediction work. After prediction, you can have the calculated retention time. And from here, you can tell how these 3 compounds will be separated under this prediction. which can give you a very preliminary idea about how you should choose your method, how your compound will perform on current method. So with those general concepts in mind, let's talk about how we can apply those two tools into our workflow. So it comes to the last part is about capabilities and the road ahead. The first is spectral application. Like we mentioned before, spectral support automatic data processing. Besides that, of course, you can do manual processing as well. This is the same database from the previous slides. So here it's a 17 samples database. You can click on each of the samples to check all the information. And for any, like here, the color shows the purities. So the red one means that sample has some problems. You can click into this sample to take a look. Actually, the purity looks okay, but just because the integration is not very right. So here you can do some manual processing, click into the spectral and try to delete all the automatic integration and do some baseline adjustment, then do the integration manually again. After that, the purity looks good. Then you can update your database by clicking on this plus button. So most of the time, the spectrals will do the auto processing with your data, like all the others looks okay. You can just go ahead to generate report. For some of them, if looks not very good, just go into the details and do some manual process, then it will look good after that. And the next step is we can do peak structure assignment. Most of the time, the peak will be assigned as the desired compound, because based on the mass, exactly that's your desired compound. Sometimes it's not assigned, so we can do manual assign from here. So once you look at the peak, knows that's the peak you are looking for, then you can click from here, drag it to the peak to make it assign to this desired compound. After that, you will have the purity information of this peak. Then you can update your database again. And even if you have NMR data collected into this database, you can do NMR data assignment based on the structure and the peaks. And another very functional function is like the search work. So we can put any keywords, parameters, and conditions to do the search work. Like, for example, you can put purity over 90%. You can put the submission date between which period. After that, you can easily find out the database you are looking for or the compounds or samples you are looking for. Once everything is done, the database is ready to generate a report. So we can click on the create files to generate a Merck template report. In this report, you can have everything included. For example, the retention time, the desired mass, the structure, the purity, and the weight of your sample. Also, the purity check, the chromatograms is included as well. And the mass spectral is listed here to show the desired mass of this compound. And on the right, you also generate a registration SD file, which is very useful for our compound registration. So here comes to the first conclusion about benefits and the future enhancements of spectrals. The benefits is very obvious. The spectrals is a new platform to expand access to data within HTTP group, or even get access to the whole chemistry department to access all the purification data. And all this data is readily protected and located. And all those automated data flow minimize a lot of manual inputs. And also the speed enhancements is achieved by automatic data analysis and rapid access. Some future enhancements. First, we want to integrate spectrals with our internal software system. As we have many different platforms, it's using across different Merck sites. So we hope we can have some integration with those to make data sharing more easily between different sites. Also, we want to get more support for centralized data access, backup, and security control as well. So then we come to ChromeGenius real application to HTTP group. So this is the same database as I listed before. This database is from a real project. We have over 1,800 data points imported here. So after we importing all the data points with these optimizations, here shows you different equations. One is linear one is square equation. As we have so many data points, it's not very obvious to see the difference between these two. But we use both of them to do prediction, to do some compare in the future work. After we have this database, we did prediction work. We imported like 20 structures. After the prediction is done, we get the calculated retention time. And also we performed real LC-MS runs to compare the calculated and the experimental retention time based on this 2-minute UPLC method. As you can tell from the difference, most of the time is pretty aligned with each other, but there's still some samples get very large differences based on our 2-minute method. So the question here is the prediction, is that accurate or reliable for our method selection, or can we make it better? So, but that's just what we finished for now. So there are some quick conclusions. The benefits of ChromeGenius is it's definitely a new tool to predict retention time, which we hope can save time on running crude LC-MS, especially for large libraries. And also, once this tool prediction is mature, we hope it could be work as a guide for our purification method selection to achieve our higher throughput goal. But how can we make it more mature to do the prediction? There are some future roles we can work on. First, we need to create more database based on different methods. For example, different gradients, different pH, different runtimes. Also, we even think about we can create a database of direct purification methods. That could be more easily to use to guide our purification method selection. And lastly, we hope we can implement ChromeGenius into our whole HTTP workflow once it shows it's very useful to help improve our workflow. So with that, I'd like to acknowledge the contributions from everyone, like my colleagues from Merck, from High Throughput Purification Lab, from Discovery Chemistry Department, people from Discovery IT and Lab Computing. And also, I want to thank the support and help from ACDLabs as well. So with that, I'm happy to take any questions you have.